The fuel planning data for the medium-range jet transport aircraft, which is abbreviated to MRJT for simplicity, is based on the Boeing 737-400. It is normal practice for the crews to monitor the fuel state using the Electronic Centralized Aircraft Monitor, or ECAM, fuel monitoring system, and compare the figures with those produced in the computer-based flight plan. However, it is necessary for students to be familiar with the data in CAP 697. The fuel planning data for the MRJT is split into two sections: simplified fuel planning and detailed fuel planning. We shall start by looking at the simplified fuel planning section. Open CAP 697 to Section 4, MRJT 1, page 1. Page 1 of this section states that the aircraft is a monoplane with twin-turbo jet engines and a retractable undercarriage. The structural limits can be ignored at this stage, as they will be the subject of a later lesson. Fuel economy is achieved by flying the aircraft at its optimum altitude, which will vary according to the weight of the aircraft. Should it be necessary to fly at other than the optimum altitude, fuel consumption will increase. This is known as a fuel mileage penalty and is shown in a table at the bottom of page 1. The calculation of the optimum altitude will be dealt with in the next lesson. Further increases in fuel consumption are shown on page 3 of this section. These include such items as operating the anti-icing system or the air conditioning, and the auxiliary power unit or APU. However, the main item of concern here is the table of cost index adjustment, which is used when the flight management system or FMS is in the econ mode. The remainder of this section contains graphs for the determination of fuel, distance and time for cruise, plus climb and descent and alternate planning from the brake release point. Each one is dealt with in the next lesson. Now turn to Section 4, page 18. As the title of this section suggests, the tables and graphs allow for the calculation of trip planning to a much greater degree of accuracy than can be achieved from the simplified planning. The scope of the data available is shown on the screen. There will be a number of occasions when conversion from nautical air miles to nautical ground miles, and vice versa, is necessary. Figure 452 on page 23 shows a graph which can be used for that purpose. However, it is strongly advised that the student uses the formula method as a quicker and more accurate means of solving the problem. The next couple of lessons will deal with each of these planning tables and graphs in detail, starting with MRJT 1, Simplified Fuel Planning. For these lessons, you will require paper, pencil, calculator, and a square protractor or ruler.